today's session. As you can see from my screen, the topic is really spectacular. It's something completely different from what we have been used to and what we've been doing on the Power BI series. So today is a fairly long title, Linear Regression Analysis for Price Optimization in Power BI. A lot of times when we hold these sessions, we've been doing much more around descriptive analysis, trying to just present what's been there in the data, insights, interactive visuals. But then, as usual, when business stakeholders already know what is happening, they try to want to project into the future. They try to want to influence the future. They try to want to be better placed to deliver value in the future. So as you can see, this is one topic that is trying to take us into that next stage of value addition and helping businesses to plan for the future. So we have Abiodun Akinfemiwa is going to be taking the session. I'm going to try to get out of his way, so I will try to be faster with the introduction. This session is being brought to you by your BizEdge in conjunction with MHS Analytics. And your BizEdge is a Microsoft Excel, Power BI, financial modeling, SQL, training and consulting firm based in Nigeria. We operate across Lagos, Abuja, Port Harcourt, but our admin office is in Lagos. So if you have people who need trainings, whether online training, class training, uh, even hybrid training, So I'll share maybe our links if you also need online training. Currently, we have some free online classes once you could register for free. So I'll share that in the link so you can take advantage of those things before they become paywalled. And then MHS Analytics is a Canadian arm. So if you know anyone in North America who is requiring consulting or training, and currently we have been doing projects for a lot of big companies. We've done projects for ExxonMobil, for VCT Energy, VCT Power, for, let me just mention some familiar names, some Mother Health, um, which other names, Pemex, a refinery based out of Texas. So we are, and Humas, a pension, the third largest pension firm in Canada. So we might not be like a familiar name yet, but we are actually gaining ground. So you can also feel comfortable in engaging us for any of your contacts here in Canada, North America, and even UK. So to the main aspect of today's gathering, our speaker is Abiodun Akinfemiwa, and he's a BI analyst. He's got over 6 years in FinTech and IT space. He currently leads the BI team at Ha-Shem, and he's a Microsoft certified trainer. He's also an alumnus of Redeemers University. He's got a degree in physics with electronics. So he's someone who it would be, it's an honor to have him amongst us to present to us, and you will learn a lot from his session. He's got the technical and the business side well grounded. So I will share his LinkedIn profile in the chat so that you can connect with him. And right now I'm going to hand over to him. So Abiodun, over to you. You can take over the screen share. Are you there? Let me go check. Hope you're on mute in case if you are trying to say something. Just hope it's not from my end. Okay, great.
Can you hear me now?
Yes. Yeah.
All right,
All
good
right.
stuff. Great.
So
Okay, thank you very much.
good. You can take over the screen share. I'll even stop now. Stop sharing.
Okay, thank you very much, sir. Just a minute, I'm going to share my screen. Okay, please can you confirm that you can see my screen now?
Yes, I see it.
All right, good stuff. Thank you very much. Hi, everyone. Good evening. Good day from any part of the world where you're going to be watching this. So welcome to this webinar on linear regression analysis with the use of Microsoft Power BI. So the introduction has already been done, so I would just do a short introduction, just in case you're just joining in. My name is Abiodun Akinfemiwa. I'm a business intelligence analyst. I have my experience across the fintech space and also across the IT space. I'm skilled in data visualization, reporting, analytics, and also in research. I'm also a Microsoft certified trainer. All right, and I'm going to be walking us through this webinar this very hour. So just to look at a little bit of my content. We're going to be looking at what linear regression is all about. We'll be looking at some use cases for linear regression, some of the tools that we can use to perform linear regression, and then we'll jump straight into the live demo session. Just a minute. Okay, so let's start out with what is linear regression. Okay, so like I have here on my screen, linear regression is a statistical model that we use to do forecast and predictive analytics. All right, so based on your historical data, you can study the trends and pattern in your data, and then you can create a model out of that data, and then you can use it to predict the future. So based on historical data, you look at the trend in your data, you look at the pattern in your data rather, and then you predict what the futuristic events what the outcome of futuristic events might be. That's basically what linear regression is all about. All right, so so there are different types of regression, but we're going to be doing a simple linear regression, right? And when we talk about simple linear regression, there are majorly two variables that are important to us that we want to analyze. All right, we have the independent variable, and then we have the dependent variable. So we have our, just like we learned in school in our mathematics, we have our x and y. So we have our dependent variable, and then we have the independent variable, right? And one of the equations we're going to be running today to test the linear regression model will be the equation of a trend line. For some of us that have the science background, we are familiar with this equation on your screen, all right, which is your y equals to mx plus b. All right, so this is the model that we're going to be, a very simple model that we're going to be simulating, and then we're going to be using that model to do some predictive analysis. All right, so we're going to be using the simple model to do some predictive analysis. So when we talk about linear regression, a linear regression model is created by fitting a trend line into a data set where a linear relationship already exists. All right. So when you want to perform linear regression on your data set, there needs to be a relationship between those variables. All right. Those variables, the dependent variable and the independent variable, there has to be a relationship between those variables. So a linear relationship should exist between the variables in your data set. Okay. So this is just a very brief summary on what linear regression is all about. All right. So next, we're going to be looking at the tools that we can use to perform linear regression. Basically, any analysis tool can actually perform linear regressions. All right. So I just have a few examples on my screen. You have the likes of R. You can perform linear regression on R. You have Excel. You can do linear regression on your Microsoft Excel. You also have Python. You can perform linear regression on Python. If you're making use of MATLAB, you can also do the same thing. SPSS, you can perform linear regression there. And then you also, I think SPSS is one of the most common statistical tool for this type of analysis. And then you also have your Microsoft Power BI, which will be the focus for this webinar. So in this session, we're going to be using learning how we can use Microsoft Power BI to perform linear regression. And I mean, beyond learning how to use Microsoft Power BI to perform linear regression, the goal of this session is to actually introduce you into how to use Power BI to perform predictive analysis. All right, as long as you have your model, how do we interpret this model with the use of Power BI? How do we come up with the interpretation of the formulas? How do we plug everything into Power BI? I studied, just like the introduction we had a moment ago, I studied physics in school. So let me just give like a little background study. So if you study physics, I studied physics with electronics, all right. And during my 4 years in school, we did a lot of mathematics. We did a lot of mathematics and physics. Basically, if you're a physics student or a mathematics student, you do a lot of mathematics, you do a lot of physics, and then I mean there are a lot of formulas and models and calculations, your integrations, your differentiation involved. And I mean, one of the things that was missing there was the life application of all of these things that we learned. All right. And then years down my experience in my career, some of the things I learned in school now made sense to me. All right. So all of those differentiation, all those calculus integrations that we did in school, these are things that you can actually apply to real life scenario when you're actually on the job. That's actually the reality. You can actually apply all of these things when it comes to real life business case scenario. You can apply all of those mathematics skills, formulas, all those calculus, integrations. You can actually apply all of them. And when I started learning Power BI and studying some learning a lot about analysis, basically, I came to understand that, oh, so all of those formulas that we learn, we write, we try to create, we try to develop, we can actually apply them on all of these tools, and then we can apply them to real business case. And that's basically what we're going to be doing today. We're going to plug into a very simple data set, and then we'll see how we can apply a very the equation of a straight line. That's what we call it. Your y is equals to mx plus b. It's called the equation of a straight line. How we can apply that very simple equation into our analysis. How we can use that very simple equation to do a predictive analysis. Now, by the time we're done with that, now think about what you can do with that's a very simple. Think about what you can do with much more complex equations. You can actually apply them, you can simulate them. And in fact, what today, these are the things that are actually driving AI, artificial intelligence, and machine learning. All right. It's all these models that are actually driving AI. All right. We use AI is already a part of our day-to-day life. All right. And these are the things that are driving all of these technologies that we make use of today. So without wasting so much of our time, because I know we really want to get into the lab session, let's just have a little understanding of what some use cases of linear regression, right? Like I said, these are things that we make use of every day, right? So when it comes to forecasting sales, all right, you can make use of linear regression to actually do a sales forecast, all right? So organizations can use the regression model to predict what their sales will look like in the future. So you have an historical sales data, and then you want to predict what will be the outcome of your sales in the next 1 month, in the next 2 months, in the next 1 year. All right, you have factors that are driving your sales. Those factors are what we call variables. They are independent variables. They are dependent variables and independent variables. So you can take all of those variables and use it to see how they affect your sales. The same thing applies to cash forecasting. All right, you want to forecast how much cash you are going to have at hand in the future based on existing data. So these are some of the applications of linear regression. You are analyzing a survey data, for example. You want to understand things like customer satisfaction, their preference for a particular product. You have the data set already. You can use that data set. You can use linear regression to actually determine what kind of product will this customer like, what kind of features, what kind of functionalities will they like to see in certain product that we want to launch or release based on existing data. All right. Then the same thing for stock predictions. All right. You can make use of your linear regression model to predict the outcome of stock performance in the future. All right, you want to analyze stock price. You want to look at the trend and pattern in stock prices over time, and then you want to use that to make a prediction. All right, into seeing what the performance of your stock would look like in the nearest future. You can use linear regressions to do all of these things just to predict the future, basically. Let's see customer behavior. All right, you can also make use of regression to see customer behavior. you want to study customers' behavior. You want to use it to know how to target your market. You want to use it to know how to launch certain products in the market. You want to see how you want to predict, use linear regressions to predict how customers are likely to spend. You want to predict customers' behavior. You want to look at the target market and all of that. So you can use linear regressions to do all of these predictions. All right. You want to see use linear regression to predict how likely you are to recommend certain products to customers. You can achieve all of these things with linear regression. So you can also analyze relationship between variables. You want to see if there's a relationship between this and that. All right. You want to see if there's a relationship between that and this. You can make use of linear regression to identify if relationship actually exists between variables. All right. So having said all of that, we'll just quickly jump straight into our demo session very quickly. It's a very simple and straightforward session. And then we'll look at the output of our results. So I'm going to be using, there's a common data set on Kaggle. All right, I'll probably share the link to that with us. And I'm going to be doing a regression on that data set. Let me see, just a minute. Just a minute. We'll go straight into the hands-on. Okay. So let me share this. Okay, so I'm sharing this view with us. So I'm going to be downloading this salary data set. And then we're going to look at we'll use it to do a very simple linear regression. This is a data set that is perfect for linear regression, where we're going to be looking at the relationship between the salary that an employee earns and the years of experience that employee has. So this is a very simple data set that we're going to be using to do our linear regression. So just a minute. I'm going to share my Power BI desktop screen now, and then we'll jump straight into the lab. Okay, it's up. So I'm going to share the screen now. Just a minute. Okay, you should be able to see my Power BI desktop screen now. But if you can't see it, you could just let me know. But I'm sure it should be up right now. So this is my Power BI desktop screen. All right, and I'm going to plug to that data set. So I've downloaded the data set on my local. It's a CSV file. So the first thing I'm going to do is to get the data. So I'll come to my get data button on my home ribbon tab, and then I'm going to be extracting the CSV file. So let's import the CSV file. Okay, so I have the data set here, salary data. So I'm just going to bring that in. So once I import the data, it would load my Power Query editor. So I would need to share that screen with us once it comes up. Still waiting for it. Connecting. Okay, so I'm going to transform the data, but I would share my Power Query editor because I'm sure you probably might not be able to see it. Okay, my Power Query is up. So let me share my Power Query. Here it is. All right, so I've just imported the CSV file. All right, and it's in my Power Query editor. So, like I said, it's a simple model, right? And then we're working with two variables, right? So I have the years of experience and salary. So I want to see how does the year, what's the relationship between the years of experience and salary? So how can I detect my salary if I have certain number of years of experience? So what's the relationship between the years of experience and salary? So we're going to use years of experience to predict what the salary should be, basically. So you can see I just have two columns here, the years of experience column, the data type is decimal, all right, it's in decimal, and then the salary. So because this is salary, it's an amount column. I'll change the data type from whole number to fixed decimal number, okay? I'll change the data type to a fixed decimal number. So that's basically all the transformation I'm going to do here. So there's really not so much to do within the Power Query editor environment. So once I change the data type, I will close and apply at the top left corner of my screen. Let's close and apply, and then let's jump straight into our Power BI desktop. So I'm going to share my Power BI desktop screen. So you should be able to see my Power BI desktop. Okay, so now it's responding. So let's check. Okay, it's still loading the queries.
Currently, we don't see anything. You are seeing your Power
Okay,
BI
it has stopped
desktop.
sharing. Okay, let me reshare. Sorry. Thank you for bringing that to my notice. Okay, just a minute. Okay, just hold on. It's loading the query. So once it's done, I'll share that screen. The window is not appearing on my Teams share screen option. So just a minute. Okay, it should be available now. Just hold on. Yeah, it is. So let's share the screen. You should be able to see my screen any moment from now. Please, at any point in time, if you can't see my screen again, just alert me, please. Very important. Okay, so now that we're in Power BI desktop environment, we've imported the data. You can see it here on my data pan. The table is there. Okay, so just a minute. So let's go to the data view and then see the data from there. And then I'll show us the formulas that we're going to use to do our predictive analysis. So this is the salary data here. Okay, I think it's still loading the data. Okay, the data is here now. So I can see that I have two columns, which is my the years of experience and the salary. So the years of experience will tell us how much salary we are to expect, okay? So before we start any work within the Power BI desktop environment, I'm going to take us back to PowerPoint and then show us that equation again. And then we're going to see the formulas that we're going to be writing to simulate our analysis. So I'm going to reshare my PowerPoint screen. Okay, you should be able to see my PowerPoint screen now. So this is the equation that we're going to be making use of, which is the equation of a straight line, right? And it's a very simple equation, which is the y equals mx plus B. All right. And we have a little bit of all the calculations that we're going to be making use of yet. But let me just quickly explain. So what we are trying to achieve is y equals mx plus b. This is our predictive model. Okay. This is our predictive model, which is the y equals mx plus b. So we can see our two variables, which is the y variable and the x variable. And then we can see the m and the b. Okay. So the m is our slope. All right, remember the equation of a straight line. So we have our slope and then we have our b-intercept. Basically, our slope is what? The change in y and the change in x, right? That's our slope. And then we have the equation of the b-intercept, right? So these are the equations that we're going to be making use of. And then the two variables we're working with is our x and y. We have the years of experience, which is the x variable, and then we have the y variable, which is the salary. All right. So the years of experience and the salary. So we want to know what our salary will be based on the years of experience. So our y is the salary, and that's what we're trying to predict. To predict the salary, we're using the years of experience to determine the salary. So the years of experience is our x. So we're going to be using our slope multiplied by our x plus the intercept. So we're going to be using this model to predict salary, which is our y. Okay, so this is what we're trying to achieve. So that's like our mission statement. We want to predict the salaries based on the years of experience, right? So the formulas that we're going to be making use of are all of these. So our x is the experience, the y is the salary, right? And then the n is the number of rows in our data, right? That's the number of rows, the count of rows we have within that data set, all right? And then I think that's basically all we're going to be doing. But to be able to calculate our slope and our intercept, we need to bring out all of this expression. Our slope is m. So to calculate our slope, which is the m, we need to find out, this is the formula we're going to use to calculate our slope, right? So we're going to have to calculate xy, get our n, then the sum of xy, the sum of x, the sum of y, and the sum of x squared. So this is all we're going to be doing. So we're going to run all of this calculation using our DAX, data analysis expression, within Power BI. So once we can compute all of these expressions, then we're going to figure out using x and y and n, we're going to calculate our slope, and then we'll also calculate our b-intercept. Once we're able to calculate our slope and our b-intercept, then the equation is complete, because we can now calculate what y will be depending on the value of x. Okay, so what we need to calculate right now is our m and our b. But to calculate our m and b, we need to bring out all of these expressions down here, from x squared to xy to n and all the way down. So let's start by calculating our x squared. So our x is the years of experience, right? So I will go back to my Power BI desktop, and then we're going to start our calculation. So allow me to share the screen for Power BI desktop. So, oops, sorry, I'm sharing the wrong screen. So I'm going to share the screen for my Power BI desktop. Yes, you should be able to see my screen now. Okay. So very quickly, I said we're going to calculate x squared, right? And our x is the years of experience. So I'm going to create a column on this table. All right. So on my data pan here, I'm going to create a new column. All right. Let's call this column our x squared. So I'm sharing my Power BI screen, my Power BI desktop screen. So if you're not seeing it, just let me know. So I'll quickly run all of those formulas that we're going to write them from scratch. Okay. So I'll just wait for it. The system is a bit slow this evening. So just apologies for that. Just give it some seconds. Okay, good. So we want to calculate x squared. So let's call this guy x squared, right? X squared will be equals to, so I'm going to take my x is my years of experience, right? So my salary data table, years of experience column, all right, it's going to be raised to the power of 2. Okay, so this is our X square. So once I press enter, it returns that for me. It returns that expressions for me. So you can see 1.1 multiplied raised to power 2 will give you this. 2 raised to power 2 will give. So that is our X square. Then the next thing that we need to calculate will be our XY. So the years of experience multiplied by the salary. All right. So on my salary data table, I'm going to create that expression again. So let's create a new column. All right. Let's create a new column. So this column is going to be my XY. All right. So let's just wait for it to come up. So I want you to relate with this, all right? So you can have a different model that you want to run. As long as you have all your formulas written out and you've gotten how to calculate all of the expressions, you can actually use your DAX to write out those calculations in Power BI, and then you can simulate your model. So we're calculating XY. So XY will just be multiplying years of experience by salary. So I'm going to say years of experience, all right, multiplied by salary. Salary will be this. So years of experience multiplied. So you could just confirm the DAX that I'm also writing in case I make an error. So that is our XY, correct, right? Years of experience by salary. So let's wait for the output. Good stuff. So we can see the figure. All right. So we've been able to calculate that expression. Now, what we want to do is to calculate measures now. All right. So we need to create some measures that we're going to use in calculating our slope and our b-intercept. So the first measure I'm going to calculate will be my n. The n will basically be the number of rows in that data set that I'm analyzing. So to do that, let me collapse this table. I'm going to create a new table where I will put all my measures, right? So let's come to table 2 so I can see new table. So let's call this table our calculation, right? So we'll put all our calculations, all our measures in that calculation table. So let's wait for it to load. So like I said, the end goal should be how you can apply this. So if you have certain variables that are linearly related, you can do predictive analytics with them. So let's look at our table. Let's call this table calculation. Calculation will be equals to enter. So it will create the table for us. And then in that table, I'm going to start creating my measures on that table. All right. So just hold on for some seconds. Let it run. My system is a bit slow today. I think it wants to close for the year. Okay, now it's up. Sorry about that. Okay. So on this table called calculation, we are going to create a measure. So let's create a new measure. Basically, the measure we want to create is our n, which is the count of the number of rows in our data sets. Okay. So this measure is going to be our n, which will be equals to, let's count rows here. So let's count rows in our salary data table. Enter. So this will give us the number of rows. Then the next calculation we're going to create will be our XY. All right. So we want to calculate the summation of our XY. So Let's create a new measure. New measure. Wow. Okay, so I'm going to do a summation XY. Let's call the measure sum of XY. Sum of XY will be equals to, so I'm going to sum, I have a column called XY, which is this guy, XY. So let's wait for that to run. So while we're calculating our sum of XY, the next calculation will be sum of X and then sum of Y. So we'll do a sum of X and a summation of Y. So remember, all of these measures we are creating is so that we can get our slope and our B-intercepts. So we're going to do a sum of X next, then a sum of Y. Okay, so let's create a new measure. Okay, finally. So let's call this guy sum of X, which will be equals to, we're doing a sum of our X. Remember, our X is what? Our X is years of experience, right? Our Y is the salary. So sum of this. So the next will be sum of Y. So let's create sum of Y now, a new measure. Okay, so let's call this guy sum of Y, which is equals to sum. So my Y is salary. Enter. So now that we have that, one more that we need to calculate our slope and intercept will be sum of X squared. So years of experience squared, the summation. So let's create a new measure. Apologies for the slow application. So let's call this guy sum of X squared. This is equals to, we'll do a sum. So X squared now, salary. So remember on our salary data table, we created a column called X squared. So we're picking that guy and we're summing it up. Enter. So once this runs, we have all the fields we need to calculate our slope and our B-intercepts. So now let's calculate our slope. Let me hide this column. So let's just wait for a while and then we'll calculate our slope. Okay, so I think we can calculate our slope now. So to calculate our slope, let's look at it. So our slope is our n multiplied by the sum of xy. So let me write it one after the other. So let's create a measure for slope, new measure. So our m slope is equal to, we're going to call our n multiplied by our sum of xy. So this is sum of xy. Then let me check again. Sum of xy minus sum of x multiplied by sum of y. So we're going to do a minus sum of x multiplied by sum of y. Okay. So I think I missed a step before now. So we're dividing this by, so let's use the divide function first of all. So I think that's what I missed, divide. Since it's slope, so we're going to do a divide. So let me make it more readable for us. So divide this, that's our numerator, by, then for the denominator, we're going to be dividing this by, the denominator will be n multiplied by our summation x square. So n multiplied by sum of x squared minus the sum of x raised to power 2. So we're going to have sum of x raised to the power of 2. All right, and then we can close that divide function, and then we can press enter. So this measure will give us our slope, which is our m, right? So right now we've been able to get the value of our m. The next we're going to calculate will be the value for our b intercepts. Okay, so let's create that measure now. So basically, our b intercepts is the value of our y when our x is equals to 0. That's our b intercept. So let's write the formula for that. So this will be b intercepts. Okay, don't worry, by the time we are done with the formula, we can start plotting our visual. All right, but let's quickly get the last one done. So our b intercept will be sum of y multiplied by sum of x squared. So let's do that. Sum of y multiplied by the sum of x squared. Okay, then we're going to take all of that and subtract it from sum of x multiplied by sum of xy. So we're going to take it, subtract it from sum of x multiplied by the sum of xy. So sum of x multiplied by the sum of xy. Then we are going to divide it. So let's use the divide function. Okay, divide. Let's bring this guy down. So this will be our numerator, and then we have our denominator. So we're going to divide it by n multiplied by sum of x squared minus sum of x raised to power 2. So we have our n multiplied by the sum of x squared minus the sum of x raised to power 2, raised to the power of 2. So this, let's close the bracket. So this will give us our B intercept. So let's run that. So now that we've created what we need, so remember we're running y equals to mx plus b, right? And we have our y. If I come back here, if I come to my salary data, I have my Y, which is my salary. I have my X, which is the years of experience. Then we have our M that we've calculated, which is our slope. And then we have our B, which is our intercept. So now we can now predict salaries based on that model, depending on the number of years of experience. But before we do that, let's go back to the report view very quickly, and then let's bring in a scattered chart. I'm just going to allow this guy to fill my screen this way. Okay. And so for this guy, on my scatter chart now, I'm going to plot my X and my Y, right? So this is something that we're all familiar with. So I will come to my salary data. Now, my salary is my X, which is the years of, my salary is my Y. All right. So I'm going to take the box for salary. It goes directly to the X axis. So I'm going to move it to the Y axis. All right. That's for salary. And then my years of experience now is my X. So I'm going to take my years of experience. Now it falls on the X axis, but it's not displaying anything because it is summing up the years of experience for me. So what I'll do, I'll click on the drop down here on my visualization pad where I have my X axis for years of experience, and I would say do not summarize. So I don't want you to summarize the years of experience. All right. So now you can see that years of experience is on the X axis, and then my salary is on the Y axis. All right, now this is our normal data set that we created, right? But you can see that there's a relationship between years of experience and salary. How do I know that? You can see that there's like a straight line that can come in between my my data points here, right? So let's plot that trend line and see what it is. So on my visualization pan, I'll come to the analytics portion of my visualization. That's this magnifying glass here. I'll click on it and I'll say display the trend line for me. Okay, so now you can see the trend line. All right, so it picks a line that is common between those two variables, right? Now I can see years of experience from 0 up to 10, and I can see what the salary looks like. Okay, so now what is the prediction in this? Because we already have a model based on this line. All right, based on this line, from this line, we've been able to calculate our slope and our B intercept. So based on this line, I can now predict what salary will look like if I increase the number of years of experience, which is what we really want to achieve. All right, so let's try and quickly do that. So the first thing I need to do is to create a predictive year field. You know, currently I have my years of experience from 0 to 10, but I want to predict into the future 11 years. 11 is not on this my data, so it's a futuristic information, right? A futuristic data. So 11 years, 10, 12 years, 13, 14, 15. I can do up to 30 to 50 years, but let's do up to 25 years of experience, right? So I'm going to create I'm going to use parameters to do that. So I'll come to my modeling ribbon tab, all right, and then I would say give me a new parameter, but let's do a numeric range. So I want to create a parameter for a range of values, right? So let's call this parameter our predictive, let's call this guy predictive years of experience, predictive years of experience. All right, this is good, right? So the data type is going to be a whole number. The minimum should be 0, and then it should increase every one year of experience. So 1 year, 2 years, 3 years, 4 years. So let's predict. So currently in our data sets, we have up to 10 years of experience, right? Let's predict up to 25 years of experience, for example. So I'm going to create, and I'll ensure that this add slicer to the page box is checked. Then I'm going to say create. Okay, so let's watch that. So I've seen that it has created a predictive X value for me, which is the years of experience, right? So you can see if I move it, let's wait for it still loading. Okay, now that it's fully loaded, now this is where it gets interesting. So you can see that I can toggle this bar for up to 14 years, and I can still even go forward as much as I want. I can see the data for up to 20 years. But this my table visual here is not nothing is happening. It's just showing me my data from salary to and years of experience based on the existing data. Now I want to use this parameter to predict the future. So let me clear this guy. Now the predictive model that we're going to be making use of is our, let me go back and share that screen. Just a minute. So I'm going to share, let me take us back to this guy. Now, the predictive model is this guy, y equals to mx plus b. All right. Now, we've used our historical data to figure out what m is, which is our slope. We've also used our historical data, which is our x and y, to figure out b, which is our intercept. All right. And then we've also created predictive years of experience, which is what we did using parameters. So we have a predictive x. Now, this model is going to give us a predictive y. And that's what we're about to create. So now I'm going to create my predictive salary measure using this formula to say predictive salary will be equals to my slope multiplied by my predictive years plus my intercept. Okay, so m multiplied by x plus b. So let's quickly do that. So let me go back and share my Power BI desktop screen. So this guy here. Okay, so let's create our measure. So let's go back to our data view. All right, now in my data view, I'm going to still on this. Now let me do it on my predictive table. So I have a table. When I created the parameters, this table came up automatically when I created that parameter. So on this table, let's create a new measure for our predictive salary. Now we want to predict what salary would look like based on the years of experience using our historical data. All right. So my predictive salary is the measure I'm about to create. So let's call this measure predictive salary, which is equals to, so remember the model y equals to mx plus b. So my m, so I'm going to say my m slope, I'll call that measure, multiplied by my x. Now my x will be my predictive years of experience. So I'm going to say predictive years of experience. That's my x, right? So all of these plus my slope, my b intercepts rather. Okay. So my slope multiplied by the predictive years of experience plus my b intercept will give me my predictive salary. So once I press enter, it will create that measure for me. Now, okay, let's wait for it. It's still working on it. Now let's go and test that measure. Okay. So I come back to my reports view. Remember, I've created my parameter here. So I'm going to bring in a card visual. All right. I'll bring in a card visual here. And with this card visual, I'm going to look at what my predictive salary is. So I'm going to plot my predictive salary on the card visual. So if I have less than 1 year of experience, I'm going to probably earning this based on our data sets. But when I increase it now, I can now increase it, see what 7 years of experience would look like. All right. And you can see from here, this is 8. So 7 is probably somewhere around here. It's close to 100. You can see this dot here. Okay. Now, if I move it up a little bit again, I've passed 10 now. I've entered 11 years of experience. On this my slicer, let me see if I can increase the font size. The value. This is my value. Values. Increase this guy. Okay, good stuff. So 20. So you can see 11. So if I want to predict for 14 years of experience, and then I can keep going 16 years, and I can keep going to 20 years of experience, 21, up to the maximum, which is 25 years of experience. So I can predict what the salary would look like depending on the years of experience for these data sets. Okay, so this is using a simple linear regression model to predict salary based on the years of experience. Okay, and this is how you can make use of your linear regression model to predict whatever you want to predict, whatever variables you want to predict. So you can apply this to any field or any data sets where there is a correlation or a relationship between the two variables. So you can use one variables to predict the other variable. So depending on what your variable is, you can now begin to apply this knowledge, this principle, using a very simple linear model to predict your variables. Okay, so this is everything that I'm going to be demoing to us for today. So this is where I'm going to stop. All right, and if we have questions, I'll be happy to take them. If you have reactions, if you have comments, I think this is where we can take that. So I'll hand over back to the moderator, Mr. Michael.
Thank you very much. So there are some questions already, and then do you see the chat, or should I read them to you? Abiodun, can you hear me?
Okay, sorry, I was muted. Yes, you can read it out. I can't see the chat actually.
Okay, all right. Okay, so let me start with Laron Paul. I saw your comment, but I didn't want to distract the presenter. I was saying maybe you share your full screen so you don't swap. So Debo asked, he said, but I think you have shown it after he asked it. He wanted to see the formula for slope and intersect on the slide. So I know you did that multiple times after that. So that's done. So Hamon asked about the error. So let me read this question exactly. He says, does it calculate error for the trend? So when you added the trend line, so he wanted to see if it gives you the details of the error, what's the mathematical term now? Wanted to see if it calculates the error for the trend. That was his question. Yeah.
Okay, so I think someone, I'm seeing the comment chat now. So does it calculate for errors for the trend? Okay, so I can see a response here. Should be a nonlinear effect as in the final chart here. Important to know the error grows as we move far from the left. So that's actually very correct. So like I said, this is just a simple linear regression, and then you can see that the trend line is not perfect. It's near perfect, but is not perfect. Like I said, this is just a prediction. Okay, so the prediction means that it can be even above, the predictive value can be above, and it can be a little bit below. So there are still there are allowances for errors. All right, but basically what this does, it just gives you an idea of what you should be looking at, not necessarily the exact value. All right, because someone else can take this trend line and plot it with a different slope, maybe closer to the dots that are below. This is the default slope that the application gives me. Okay, so there are obviously there are going to be some one or two forms of errors, but it's not so far from the actual values.
Okay. Let me just keep checking. All right, so I don't see any other questions. I just wanted to say that when I used to do this in Excel, so I tried to use a bit of I think they now added those formulas to in Power BI, like Linest, Line. I think they added to Linest and Linest text. So it makes it possible a bit to compute these least square error concept. I mean, per variable. So like the intercept, the slope.
Yeah.
So they could generate them together for one. But this is better. This approach makes it easier for people to follow because that one abstracts away. I just said I should maybe just also point out that there is a possibility to also maybe use the Linest to not need to calculate the breakdowns. I can try to share the formula. I mean, it's well, not that it is very new, but it was not always in Power BI until a bit of, was it? I don't know exactly when they added it, but thank you very much. A lot of people followed, and a lot of people clapped. So I think this your approach was a much more thorough, easier for people to follow and understand it from the first concepts. The slides you did. Thank you. Any other questions from anyone? So while we wait for more questions, I can pull up the house questions. So house questions are questions that we ask all our presenters. And question number one will be, there are two, but I'll pass them to you one by one. So question number one is how you got into this space to be. You would like to hear your journey, how you got into data analysis and Power BI and what you do now.
Okay, thank you very much, Michael. So, how did I get into data analysis? Well, it's a very interesting story, but I'll try to be as brief as possible. I started my career as a business analyst then. I was working in a fintech company on the island as a business analyst, so just doing normal business analyst stuffs and all of that. And then my CFO saw me one day, and then he called me and was like, "Hey, guy, you studied for it wasn't like he was an Ethiopian, sir, in Nigeria here." He called me and was like, "Ah, you studied physics, you're analytical. There's this new application by Microsoft called Power BI and all of that. I want you to go study, take a look at it." Well, so casually, I just said, "Okay, no problem." I mean, this guy's wala is almost too much. So I mean, I just took a look at what Power BI was all about. I went online myself, and then I started reading up. I was watching YouTube videos, and then I met the tech guys in my office, installed the application on my laptop then, and then I started practicing. I saw a lot of videos. I was learning on my own, and that was it. So I literally learned data analysis on my own. It was more like self-taught by making use of all the resources online and all of that. And then when I left that job, the new role I took was now a BI role. All right, and that's where I now started making use of that knowledge in my field actually. So I started working on projects, started working on applications, started collaborating with the Power Apps developer guys to build solutions. And that was how I came fully into data analysis. Then another thing that helped me in my new role, my CTO, MJ, as we fondly call her, actually encouraged me to start training then. And so I started training. And in a very short period of time, I got my MCT. So that boosted my confidence a little bit further. All right. And then I did a lot of training. I started doing a lot of training after then. All right. And then I realized that the more you train, the more you teach, the more you know better. All right. You might have a knowledge of a thing, but when you teach it, you see it in a different light. All right. And then you just keep improving that way. And currently on Scalable, I've trained over 100 students. I know it's still a very little number. I mean, but it's a milestone. All right. So that's how I got into tech. Basically, I learned on my own, and then I started training, and then I improved on the job. And currently today, I've worked on several projects, and I'm still working on a lot of projects. All right. And then coming into my current workplace, I was introduced into the community. All right. And then I met a lot of very nice guys like Mr. Deji and the likes. And this was also a part of my learning process, because when it comes around to our office to give a talk, I learn from him literally every time he speaks. He's almost like my favorite tech speaker, as it were. So that's basically how I learned. I started out by making use of resources online, and then I had to put in my own practice hours into it. And then the opportunity came for me, and then I could now flex my muscle when the opportunity came. So that's really the journey for me in a nutshell.
Oh, thanks. Interestingly, too, I know a few of the people you've mentioned their names, so it's the ecosystem is like many people tell us that we need to be part of the network of people, community of people who are already ahead, and the motivation and the insight that comes from them help a lot. The second question, which we ask every presenter we bring in is their advice. So if there's someone trying to start out now, what advice will you give that person?
Okay, so the same advice or the same pattern that actually is if you are trying to start out in the tech field, it doesn't have to be data analysis, it could be anything tech related. But if you're trying to start out, then I think the first thing that you actually need is that passion or that desire that you really want to start out. Then you can start learning from the little that you can. For me, I had to go online to actually source for knowledge, look at materials, get materials, watch videos. And then another thing you can do is also join a community. All right. If you're starting out in tech, I mean, we build and develop ourselves. We all learn daily. The Microsoft Power BI as it is, they update the application every month. So join a community where you can learn. If it's possible for you to also get a mentor, that would also help. You have someone to check on your progress, someone to monitor you. So, but I mean, the most important thing is that you need to have that desire to learn. So start out, know what you want to learn, and then start learning it. If you need to get free resources, there are a lot of free resources online. There are a lot of videos you can watch. You can put in your practice so that when you have that opportunity, you can showcase that, okay, this is what I know. Let me tell you from my own experience. I remember when I went for my interview, then I was at Ha-Shem where I work currently at. MJ called me and she was like, okay, send me a sample of the reports you've done. And then I sent her something. And later when I came in, you know what she told me? She said, when they shared it with management before my interview, that they just laughed. That what is this? Like, if you see my first report, they didn't look like rainbow. You know, coat of many colors. That was how my report, like I had done. It was just like I was just playing with colors, basically. But she said something to me. She said, even with all of that, what stood out for her was that he was able to build something. Do you understand? So perfection is not required when you're learning. All right, because you keep learning every day. But because I was able to come up with something, she said that that was sufficient for her. By the time I came into the job, give me a space of how many months? I mean, 1 month when I came in, I became an MCT. So that's to tell you how fast my growth was. And for you to be an MCT, you must pass at least one Microsoft certification exam, a major exam, and then you should also have one or two experiences, training, and all of that. So 1 month into coming in, I became an MCT. Few months down the line, I had trained certain number of students, I've worked on delivered certain number of projects. So that's the advice I can give you, right? Start learning. It doesn't have to be perfect, but start. When the opportunity comes, even that little project that you have, when you showcase it, someone who can really identify talent will see the talent in you, and then they can now help you to develop on it over time. So that's the advice I can give to anyone who is starting out.
Oh, thanks. Okay, so chance for guys and ladies in the house who still have questions. Any question to Abiodun before we close for the day? But thanks a lot. Those are very, very practical answers you've given to how one can, I see people clapping, how one can, you know, without getting bogged by all the options and many things, take a very direct way to becoming someone or that is adding value, not waiting for perfection, just sticking a foot in the door and just making sure that you are maximizing whatsoever you are learning and adding value wherever you are. So thanks. I'm checking. I don't see any other questions, but I've shared your LinkedIn connection link on the chat, so I'm guessing people will have sent you connection requests. Yeah, we are very happy to have you today, and thanks for the session. And it's been a long time we've seen someone utilize what if parameter, so that's another very big plus, that you've helped us to also take a learning on, apart from even the core aspect of what you had planned. So thank you very, very much. Uh, and at this juncture, we are going to end today's session. Thank you to everyone who has joined. I know some people had to leave before the end, but that's why we have the recording so people can watch the part they missed. So thank you once again, Abiodun. Thank you to everybody who has joined today's session. See you next week. I think next week is the one before Christmas itself. So I'm not going to wish you a Christmas yet, but see you next week. Thank you, everyone, and bye. Thanks again, Abiodun. Thank you. ending the session now. Bye.